Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I'm going to do something a little different. I'm going to do a kit. I haven't done enough kits around here. I like building kits. I loved it when I was a kid, and I still love doing them today. So I got a couple of these. These are, I'll open it up and I'll show you what it is. It has no description. This is a, read the board, it says a DDS signal generator. So it has the LCD display, potentiometers. It's got a couple outputs. So it does like sine wave, square wave, triangle. And it's just a basic signal generator. And I bought these, I can't remember, I probably bought them on AliExpress. You can buy these for less than 20 bucks on eBay and AliExpress. So if you're interested in getting one of these, it's not a bad idea. Pick one up because they're cheap. But these aren't really great test gear equipment caliber things. They're just basic for getting a signal that I want. And this is actually a component of a building block of something bigger I'm putting together. I want to put together a stereo encoder and stereo multiplexer. And this is the one I'm working on. I haven't worked on it yet, but I have the board and the chips. And I want to build this. This is a stereo generator. So what do? You feed in your audio, your left and right audio back here on this side, and then out here you get your signals. I got the board here. This is the board for the generator. It's a stereo encoder, it's called. I don't know if you can read the top. Broadcast multiplexer. And it's by this Greg. Can't pronounce that. Panagotio? I don't know. Sorry, I butchered your name. And this is where the board is from. If you go to this, they have a website.com. This Motolius. They have a website, and you can buy these boards. See, here's it's got it marked 2014, so this board's already 10 years old. Oh, there's the website right there. Yeah. So if you want to get one of these, go to this website. He'll sell you the board for less than 20 bucks plus shipping. And it's a really nicely constructed board. It's got a PIC controller on it and a couple of logic chips, and the rest of it's mostly analog stuff. And you get 3 signals out. You get multiplex, RDS, and your pilot tone. Yeah, so this is the main project I'm working on, and the big hurdle for this one is that I got the PIC chips, but I got to get my programmer up and running because I need to program the PIC chips for this project, and I haven't got that yet. So that's a future episode. This is episode for today. So let's actually go through and build this thing. Get rid of this. It looks like a one-chip solution. What is this thing? Oh, this is at Mega 16. So I'm assuming this thing's already programmed for what it needs to do. And we have an LCD display. A 1602A, and it looks like it's lit, backlit. We've got our resistors, got some standoffs here, some push button switches, a crystal, trimmer resistor, some ceramic caps, and some, looks like some other capacitors. So let's put this thing together. Let's see here. Let's do this. Let's get our resistors first. Okay. I always have troubles reading these 4-band resistor codes. So that looks to me, it's brown, black, orange. So is that 100K? Let me see. My tester out here. Yeah, 100K. How about that? Okay. So I think to make life easy, I'm just going to put the board in this vise. Will it work? Can I open it enough? Ooh, it's stiff. Do this. And then I'll just secure it in this vise, and then it's held for us. Okay, so we got our 100K. Yeah, like I said, I love building kits. I think there's it's a relaxation thing for me to put something together. And then when you find out at the end if it works or not, and if it doesn't work, you get to troubleshoot it and figure out where you screwed up, because obviously you screwed up. And what is this? This is brown. Got a brown stripe on each end and 3 black stripes in the center. So what is that, 10 ohms? No, it's 100 ohms. See, I'm not very good at these. Where is the 100 ohm resistor? Right down here. Okay. And these are all 120. No, if I read it from this way, it's black, sorry, brown, black, black, red, so that would be 10K. It's a good exercise in learning these new four band codes. So they got 10Ks, so that's these. I remember when I was a kid, the Radio Shack had, you could back in the 70s, you could walk into a Radio Shack and you could purchase a blank printed circuit board of a kit, and it was cheap too. You could afford it when you were a little kid and you had no money. The thing was that they could sell you all the parts too, all the components, the capacitors, transistors, chips, whatever you needed. It was all on the shelf, and those were fun too. Especially because you didn't have to buy all the parts. You could salvage parts out of an old radio or something and then use those parts to build your kit. And quite cost effective. You could build something for like less than nothing. I think I still have it here. I built one of their frequency counters. It was a digital frequency counter. You bought the printed circuit board, and you could buy the project box to go in it, and it had a printed, for the front panel, it had a printed sticker with all the, the layout, and it was all laid out and pre-done for you, so you could just put it all together. It looked pretty good when it was done. And I think I used that. I think I still have it kicking around here. The old frequency counter. Oh, hang on here. That's 20K. What am I doing? 10K. Okay. Okay, I got a 10K up here. That's what screwed me up. And that's it. 20K, 220, and I have a couple extra. What's going on here? Alright, so these are 20K, I'm assuming, because it's red, black, black, red, brown. Let's measure one. 20.1K. So what are these? This one is 220 ohms, I think. Yep. Okay, so that goes up here. And then, what is this? That's a 10K. I don't need any more 10K, so I have an extra one. What is this? That's a 12K. Why do I need a 12K? Oh, right here. Okay. Now I have this one. This is a 20K. This is boring for you guys, I know. But it's a good way to kill some time on a weekend if it's got bad weather outside. And you got nothing better to do. Okay, what's this? 10K. An extra two extra 10Ks. 4, 6, 8. 4, 6, 8. Okay. Should have enough. Velman makes kits too. I've never actually built any of their kits. They used to sell some decent kits. Up until, I don't know if they still do. I think they still do. They had some cool projects, but they were kind of more like building blocks. Like you could make a preamplifier and then you could use it to make something else with it. There's lots of kits like that. I like the ones that come from China because they're, you know, it includes all the components. They're cheap, yeah, and they're not the best quality, but they're fun. And it's good entertainment. So let's see, we pack these ones in, and then we're done with our resistors. And then, from what I just recently learned, Heathkit is back in the business of supplying kits again. They have a website. That's where I found out about the meter board from our IG-18 signal generator. I think I might just order one because it's a complete kit, and you know, comes with the board and little few parts that go on it. It's just a little buffer board that isolates the meter circuit from the output and provides a high impedance, so it's not a low impedance load. Okay, let's solder that up. Get my iron out. They're all down. What I'm going to do is I'm going to solder one side from the top. Let me see here. And then I'll flip the board over. This will just hold them so they don't move. Oh, just sit down. Now I was looking at this board, and it's got 3 voltages for power supply. I'm not pleased about that. I guess the chip needs the 3 voltages. Which complicates things in the power supply end of it. want them to sit down so it looks all nice and neat. I'm on the camera and people are watching. I don't want it to look shoddy. Okay, they're all secure. Let's flip this over. And we'll solder from the bottom. Yeah, get rid of this. Okay. I have to start cutting wires because it's in the way. Pretty tricky when you have this forest of wires sticking up, and you have to get your solder in it. So leave comments down below with your kit building experiences. I know some of you build kits too. I think a lot of us have. What kind is your favorite kit? Is it audio? Is it test gear? Is it stuff for automotive? There's lots of different genres of kits. I like the test gear ones. You put together something and make a piece of test equipment. It's useful, you can use it. I also have some other stuff in the works that in the background that I haven't shown anybody yet, and it's putting together an audio system, but I'm using like Chinese parts and stuff, and just kind of a bomb thing I put together just as a kind of a nothing. It's not nothing serious. It's not serious audio gear. It's just something that's kind of a laugh, just to see what we can do with the kits that China supplies, what kind of an end result you get, and if it's kind of fun to put together. These Chinese resistors have magnetic leads. They stick to everything. All right. I think we're set. Resistors are in. All right. What's next? We've got a crystal and a couple of caps, trim pots. Let's put this stuff in. .104. It's 100 nanofarad. 22 pico. Crystal. 16 megahertz crystal. Another 22. Another 100 nanofarad. Okay, let's just tack these ones in. And these, tack these in too, I guess. All right, let's flip this over. This one goes relatively quick. There's not much to it. I thought there would be a little more complex, but it's actually a very simple kit. It's 2 chips, and I think a few resistors and caps, and that's it. So push this crystal flat to the board. Okay. I think that's it. That one better. Okay. All right. We have a header. Let's put the socket on first. Here's our chip. This is a 386. Can't even read that. Yeah, LM358. Okay. Let's do this one first. Tack the corners, and then I'm going to push the chip down flat to the board. Okay, it already was. All right, got one down, one to go. This is going to have to lay down a bit because you only got so much room here. So let's fold this one down, and then this one. Tack the corners again. Working on a frame here. Let's not do that too much. go through and do them all. I can't imagine doing board soldering and building kits or building a board for a living. The way they used to hand solder everything before they wave soldered, it's incredible the amount of work that went into doing some of the stuff that they made back in the day. You gotta appreciate the people that built that stuff. They probably didn't get paid much. Manufacturers would pay them as little as possible to keep costs down. And then when they moved everything overseas, people lost a lot of work, a lot of jobs. Things that were built in North America were no longer being built. Those jobs are gone forever. All right. Last one. There. Give it an inspect. And no solder bridges. Everything's good. All right. Let's get our buttons in. I got 5, 6 buttons. Now I'm thinking about how I want to use this. Let's see here. I want to have it mounted on a front panel of a piece of equipment. So these here, if I mount them to the board, they point forward. Right? And then your potentiometers point forward as well. But I want the display, so I'll make it a ribbon cable instead of using that header. I might use a ribbon cable and put it together like this. Yeah, I think I will. Okay, so let's do switches are a problem. Well, I'm going to have to remove switches later and put them on the front panel regardless. So let's just get the switches in now to, let's see, we got some switches here. Just temporary like. Six switches. Yeah, I'm not pleased with these switches either. I'll put them in temporary. These will get moved to the front panel as well. Might have to put some extension wires on them or something, or use a different switch. Let's see here. Little leads are a little bent up. That's why they're having troubles getting it installed. Okay. All right. I'm only going to solder 2 of them on each switch so they're easy to remove. I'm just going to do that one. Okay. Oh. I'm just soldering the ones that have a connection to ground. You know what? I think I'm just going to do them all because then it probably might not work if I don't do them all. Just makes it more difficult to get the switches desoldered later. So here we go. Okay. Good. I missed one. All right, now let's get this trim pot in. I don't know if this does. Now I bought 2 of these kits. I don't remember why I bought 2. If I had plans of putting both of them. I only need the one, I think. It's just a tone source. That's all I'm after, is just something that creates a tone for the stereo generator. Okay, we have 2 potentiometers. One is 50K, and the leads are all messed up. Straighten this out. I had a bad day. Okay, 50K goes here. Sync it to the board. There. And we can finish the other 2. And then we have a 1K. Nice little pots. Okay, those are in. I don't like the way they're so close together. Amplitude and offset. Yeah, that's really... You put knobs on them, they're going to be banging into each other. I might have to move that as well. All right, what's left? That's it. We're done, except for our B and C connectors. I'll put these on. Come on. There we go. Okay. Let's trim this. So everything's good except for, well, hang on here, hang on. Let me see something. It's awfully close. Get another one. I guess there's enough room there, just barely. Okay. I'm not going to be using these very much because HS out, DDS out. I don't know what the difference is. I'm not going to be using these too much because it's going to be wired internally to the multiplex board. So the potentiometers might keep those, and I don't know. I'm not pleased at how everything's crowded here in the front. If I put this on a front panel, it's going to come through, and we're going to see that, which I suppose is okay. Amplitude's okay, I guess. Yeah, I'll have to live with it. Can't have everything you want in life, right? Let me get some ribbon cable, and then we'll attach the display. How many pins do I need? And what do I got here? These are 9. This one is 7. 7 and 9 is 16. Will you look at that? So I could use these. Pull this off. This is salvaged from something. I don't know what. It's probably a receiver or something. I'm not going to use these end things, although they do help keep the cable from breaking, from flexing, but then I don't have the holes drilled for the 2 anchors. Just going to pull them off. Just like that. Now this goes like this. So if I extend this here, what do I need? Going to need about 100 centimeters, or 10 centimeters. 100 millimeters would be enough. Okay. So let's cut these to about 10.5 millimeters, centimeters, sorry. There's that one. And then this one. .5. I'll leave a little bit for soldering. Okay. Get those stripped. Somewhere there will work. There we go. All right, let's do this. So we have to go from behind. Straighten these pins out. Okay. Good. Let me fold this one over. Fold this one so it doesn't fall out. And then we'll get this one. I don't think all 16 are used. Maybe they are. I was looking at this, and there's some holes here that don't have no connection to anything. So I don't think they're using all of the 16 holes. They're using maybe 12 of them. So here, put this one in. Come on. You know you wanna. There we go. All right. Okay, let's solder this before it falls apart. Gold-plated. I'm so happy. Another thing I want to build, I have bought parts for, is a amplifier load. I have bought a whole bunch of 16 ohm 100 watt resistors, and they're going to be put into parallel to make 8 ohm and 4 ohm or 2 ohm, whatever I want. So switch those resistors in or out. I just need a box to put it in. I got heat sinks here already. I have fans, fan controller to do the cooling business. I want to make it a standalone load for amplifiers. Okay, looks good. And that I need to do that sometime quick because I have to retire my other I just have a couple of resistors tacked onto a heatsink, and it's really inadequate. I put several hundred watts into it, and it gets very hot very quick, but it's just not ideal. I want something that's more permanent, and probably something that's going to be attached to the bench so that it's out of the way. I just have to hook wires up to it. Alright, got that done. Now all I have to do is get this side. So I don't know if I'll make videos of that. If you guys want to see that stuff on video, let me know and I'll see if I can figure out a way to make it work so it's entertaining for you. Not so boring like this. There we go. Got it in. Okay. Let's put this like this. And then I'll solder this side. Oops. Okay. Problem with these ribbon cables is you can't flex them too much because they'll snap. So once I get this put together, it'll be okay. And that's the beauty thing about a kit too, is you can modify it to suit your needs. You don't have to build it the way it's presented. You could build it any way you want. You can build it into something else. You can disguise it as something else. You can use it as a building block for something bigger. These cut off because they will definitely fold over and short. Got these a little too long. Alright, we are done. Let's get some alcohol. Get this cleaned up. That's better. See any defects? Some of these are low on solder. Yeah, I should resolder those ones. Looks like a little, too little. So they were soldered from the top. Okay. And we still have a couple of these that aren't soldered. We're good now. All right. Load our chips. Pin 1's up here. Okay. I don't know why they put it in this foam. That's not conductive foam. I'm pretty sure of it. It has to be either pink or black. This is just regular foam. I'm gonna need, let me try it from this way. There we go. Get that satisfying crunch. Now you always take a look down between the socket and the chip, and you look for any legs that have folded up or bent. If you look through there, through that little window, you can see that there's no chips folded under. Everything's good. So we're complete. We need power now. I did this upside down, didn't I? No, that's all right. No, it's good. Because it goes like this. That's right. Perfect. All we need now is power. +5, +12, -12. Yikes. Alright, so I attached some wires. We got... I'm assuming that plus and minus 12 volts is just to run this little op amp, and then the 5 volts goes for the chip. So let's connect the 12 volts first. Here's ground. I got 3 different power supplies here. I don't want to mix them all up. This is 12 volts. 12 volts negative. And then positive is this wire, I believe. Yep. Okay, no current's flowing there. The other 12 volts is here. This will be on my negative supply. So connect the positive here. This is janky, I'm telling you. Ooh, careful. Alright, connect this to negative. Still sitting at 0. Here's our 5 volts. See, this is stupid. 5 volts negative. And 5 volts positive. We got nothing. Nothing's blowing up. Well, this is embarrassing. We've got nothing. What's going on here? +12. Let me check my wiring. +12. This is -12. And 5 point. Oh, this came undone. Oh, look at that. Okay. So we got some action going on here. We got a sine wave. take this off. You see it better? No. Try that. So that's working. Let's try the buttons. High speed, 1 megahertz off. Can you see this? So we got 2, 4, 8 megahertz. Noise off. Random noise. Frequency step 100 hertz. 1 hertz, 10 hertz. Okay, that's have to figure out this menu. On, there we go. Now, let's connect up a scope and have a look. Alright, that looks terrible. That's not a sine wave. I think our offset is not set, so let me turn the offset. If I turn it clockwise, it disappears. If I turn it counterclockwise, it looks like we're getting our signal. Both halves of it. Let's turn this down. Oh yeah, there it is. It's very noisy. It's very noisy indeed. Okay, so this offset thing, yeah, that has to be set properly. I don't know why they gave us a knob for that. Why didn't they just make a trim pot on the board and we can adjust this? So I'm playing with the knob right now. Okay, amplitude. Okay, that's working. That's full. Turn it down to 0. Okay, that's working good. Frequency, I have to go through the menus and set. Let's try sweep. Let me see here if I can figure this out. Sign off. No, I want it on. I guess I have to turn it off before I can switch anything. Now let's try square wave. Oh, that's not a square wave. That's pathetic. Yeah, these are not great generators. Let's try the offset. And there's our amplitude. Okay, let's try triangle. Triangle, here we go. There, that looks not too bad. Okay, sawtooth. Everything's working good. Reverse sawtooth. There we go. Yes. ECG off. Okay, let's turn this on. What does that do? Oh, that makes like a little heart beep. Kind of interesting. Why would you want that? Unless you're on a movie set. Turn that off. Frequency step. 1000 hertz. Random noise. Okay. It's like a digital noise. Yeah, it's a digital noise, all right. Just random steps. High speed 1 megahertz on. I think that comes out the other B and C. So let's I'm trying to get to the sweep one here. There is a sweep one. Frequency step 100 hertz. I don't know what. frequency step. No instructions. Okay, let's go back to sine. We got a sine wave. Let me set the to 1000 hertz. Let's measure distortion on that sine wave. Okay, let's set this to 10. Let's read the distortion. So we have a 30% scale. We're measuring 20% distortion. Is that correct? Wow. Let's do a high filter. Let's do a low filter. Now we're down to 9.5%. It's terrible. So it's not good for much of anything, eh? Terrible, terrible, terrible. We're at about 9% distortion, and it's fluctuating. The filters. Take the filters off and we're up around 21% distortion. Well, there's a signal on the HS. I think that's high speed, so I think that would be our megahertz output. So let's try and trigger that, playing with the menu here. That is not audio. Turn that off. Let's go high speed. On. There we go. And what do we got here? There's our high speed, 1 megahertz. Looks pretty spiky. And we have no amplitude control and no offset control. This is just straight out of the chip, I'm assuming. Let's see if we can turn this up to 2 megahertz. It's 2 megahertz. Let's try 4 megahertz. 4 megahertz. 8 megahertz. Ay, ay, ay. Look at that garbage. Is that 8 megahertz? It's not stable. So I can't highly recommend these signal generators for anybody. So I'm kind of rethinking my use of this signal generator here. Is not going to be that great. It's going to provide a real dirty signal unless I can clean it up somehow with filters or something. I don't know. I don't need pure tones from this thing. I just need a tone, period. Just something that's adjustable and I can feed into my stereo multiplexer. But yeah, these are kind of poor performing. I wonder what this trim pot on the back does. Is that something? Oh, that's contrast for the display. Okay. You can see that. Why is it glitching? I know it's weird. Let me try adjusting this again. like it's... Did I lose power? Is it broken already? Oh my god. Let me kill the plus 5 volts. Maybe that resets it. Okay, going back on. There we go. It's behaving now. Yeah, I don't know. These are very cheap and not very high quality output. If you just want a quick and dirty signal, I guess they're good. Something to play around with. Something if you just want to have on the bench. If you want to feed a signal into an amplifier or something, you're not getting good, clean sine waves out of this. And the square waves look horrible too. So can I recommend it? No. Is it fun to build? Yeah, it was a cute little thing. Took no time at all to slap together. But performance really isn't there. So one thing I would recommend if you have one of these is adding some bypassing capacitors. There's absolutely no capacitors here in the power supply for bypassing any of the digital noise that's coming out of these chips. Yeah, you're going to need bypass capacitors on the power supply, and that would clean up a lot of that distortion and noise that's coming out of this. So what I propose to do here is just add maybe some capacitors to some of the power supply rails. See if we can clean up that noise. Let's I forgot what it measured before, so let's connect it up and measure the noise, or the distortion I should say, of this generator. It's quite high, so I'll get the power hooked up and we'll do a measurement. Okay, we are connected and we got the sine wave at 1032 Hertz. I don't know why it came up with 1032 when I switched it on. Something maybe in the chip glitched and just made a random number. Actually it was at 232 and I adjusted it to 1032. Sine wave's on. Got our sine wave on the scope, as you can see, and here we have our distortion meter, and here we have our distortion meter ready to take our measurement. So we have it set up, and for calibration, let's read this, and let's turn this up. On the 30% distortion, 10%, 3%. Okay, so we're on the 3% scale. We got 1 point, what is that? I can't see. 1.3, yeah, 1.3% on the 3 volt or 3 scale. 1.3% distortion. Now our filters, let's try high cut. See, a lot of the distortion we're getting is high energy noise or high frequency noise. And if we put a weighting filter in, we can measure our distortion has dropped to 0.47%, so less than 0.5%, which is better, I guess. Let's see if we can get a better reading on that with adding some bypass capacitors. Okay, there's our baseline. Okay, I'm just going to confirm my ground and power pins, or the power pins anyway, on at mega chip. So this is plus 5 volts, and it should be pin 10 is our power feed. So I count from pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have continuity there. That's our power, and our LM358. It looks like they're using a split supply here of plus minus 12 volts. But these can be powered from single-ended supplies. If you ground pin 4, you put your power on pin 8. So pin 8 would be positive. So if I go from positive, pin 8, yep. And if I go negative 12 to pin 4, that's correct. What they're doing is they're using 24 volts to power this chip. Okay, good. We know we have our points, and my plan is just to add These are 470 nanofarad MLCC chips. These are 0805, I think, size. I'm not sure. And what we'll do is we'll tack on the back where we can. There's pin 4. We'll tack a chip on and we'll ground it. A chip capacitor on and we'll ground it. Pin 10 is from this side. 1, 2, 3. 10 there. So we can just scratch the mask coating off and just solder our chips directly to the board. Okay, let's remove this. Let's start. I'll get my iron warmed up and let's start scraping. Where is my tool? Here we go. Got a little flat screwdriver. So we got to confirm this again. Pin 1 is here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right here is our connection. Scrape this back. We'll solder right to that trace, and then we'll solder back here on the ground plane. Okay, that should work. Can you guys see what I'm doing? Try and zoom in a bit more. So I just scraped back the solder mask. Okay. Now we need pin 4 and 8. So where is pin 4 is down here. This is pin 4. Scrape back. The solder mask is quite thick. That should be good. And then pin 8, we really don't have a ground next to pin 8. We have a little island here, which is not connected to anything, but we can run a jumper from the island to the... So let me scrape this back. Scrape back quite a bit of it. All right, okay, let's get our chips out. Where are... This is the part where it always drops on the floor. Okay, we got one. Let's start with one at a time. All right, a pair of tweezers, a good pair of tweezers, and our iron, the hot iron that's clean. Let's see here. I need to tin this pad. Okay. Okay, here we go. There, did it. Let's solder this end. I didn't scrape back very much. I should scrape some more. That should work better. There we go. Tacked in a MLCC capacitor. Can you see that? Come on. There we go. So it's jumped from that line to ground. And we can check for shorts, but I don't think there's any shorts. We'll do the short thing after. All right, let's do our op amp. Let's put a couple there. So where's our op amp? And where's our chips? I lost the chips. My bench mat is actually camouflage, so I can't find anything. Oh, here it is, under the roll of solder. Okay, let's get another chip. I often do this on audio equipment too, if I feel that there's not enough bypass capacitance or filtering on a circuit, and it will improve if I add some. I usually just scrape back the solder mask, tack in a little chip capacitor, and there you go. It's quite easy to do. Okay, I'm back. Sorry about that. Where did my chip go? Oh, here it is. Okay, let's try and plug this one on. It should be fairly simple. Oh, look at that. My tweezers are magnetic. What a joy. So I heat up this joint. Actually, let's put some solder on that joint. Let's get it. There we go. Got lots to solder to now. Let's put this one here. Okay. This side. There we go. Now let's do the last one. This one's going to be a little more fun. Okay. I think these are 470. They're marked 470 nanofarad. But I've had these come. These are the kits you buy of different values. Let me measure this and see what it measures at. Okay, this is going to be tricky. There. Comes back at about it comes back at about 417 nanofarads, and it has an ESR of 35 ohms. So this is actually pretty good little caps for their size. You probably put a film cap in there, the ESR would drop to about 1 ohm, but it'll also be a big bulky thing. Let's add some solder here, and my tweezers, and let's solder this one in place. This one, I need to angle it more. Good. Let's solder the back side. Okay. Now what I'll do is I'll just get a little wire and jump right across to the ground connection here. But let's check for shorts. Make sure we don't have any shorts on any of these caps. So where are we? Good. Good. Alright, cut a little piece of wire here. Let's tack it in place and jumper it. This is silver plated wire wrap wire. It's copper with silver plating on it. So generally you don't have to tin it, it just sticks very well. So I just go in here and tack this end. Okay, and then bend this around. Solder this one down. Alrighty. Let's do this side better. Okay. Alright. Let's power it up and give it another test. Okay, we're powered up. Let's do the measurement. It's running at 1032 hertz. Let's turn this thing on. There we go. And we should have put this into calibration mode and set it full scale deflection and put it to read. What are we at now? 10%. We're at 2.5%, 3%. Something's wrong. I think I might have bumped the, let me turn on the scope. I might have bumped the offset. Yeah, I did bump the offset, and look at how it's, you can see how the top of the signal's cut off. So let's reset this so that we have a good sine wave. There we go. Put it right in the middle. And let's do our measurement. Okay, turn this down to 10. Turn it back up. We're on the 1% scale. We are sitting at 0.75% distortion. If we hit the weighting filter, it drops to 0.45%. I don't know if that's any improvement or not. I think it's a little improvement. It's certainly a usable signal now. I can use it. It's only 0.5% distortion, so it's, I could use this signal for my stereo encoder. No problem. Yeah, I think I will. Seems like I could go further too. I could add some electrolytic capacitors to where the power comes in and put those on the board as well. That might even bring down noise a little further, but I think we're probably hitting the limit of this Mega 16 chip. Hard to say. Hard to say. Well, there you have it, start to finish. I built one of these and it works, and we made some little improvements to it. Maybe, I don't know. This looks crooked. But enjoy building kits. If you want to see more kits on the channel, leave a comment below and let us know what kind of favorite kits you like building, or maybe kits you'd like to see built on the channel. I could order them up if they don't cost too much. I've already got a couple here. Here's one that's kind of a, let me open this up. This one I bought as kind of a joke. It says it's a 300 watt stereo amplifier. Yeah, look at it. And here's our circuit. There's no bias adjustment, there's no front and long tail pair. The printed circuit board is very flimsy and cheap. It just looks like they have tandem outputs, and that's where they're getting all their power from, just high current. I got all the parts, and I even added in a little power supply board with speaker protector circuit. I threw this in here. I don't know if I'll even build this one, but here's the info sheet on it, so you have a look at the schematic if you want to pause it. I have a feeling this is just a garbage amplifier. It barely works, or if it does work, it's probably full of oscillations and distortion and stuff. So this might be interesting to build, but then I don't know. I bought this on eBay as well. It wasn't very much, so that's one option. Another one here, a little higher end. Let me show you. So this is another amplifier kit I bought, and it has two printed circuit boards, one for each channel, and they're mirror images of each other. So these have 3 outputs per channel. So here we have the 2SA 1943s and 2SC 5200s. They're big beefy transistors, and they're putting 3 of them in parallel. A lot of caps, a lot of room for caps, and this, it says 0 dB amp version 1.0. Now I don't see any input stage or voltage amplification stage. This just looks like drivers and outputs. That's what that looks like to me. And power supply. It's got power supply. It's got speaker protection circuit, and that's it. There's no input circuits. So what do you gotta design your own? Or maybe I should just use this. I don't know. But it looks like a pretty beefy amplifier. I can't remember what I paid for it, or when I bought it, or what it said. But it just says 0 dB amp right here. And then this is, I think, is the right board, and this might be the left. I'm not sure. So if you put them together, you get quite a big. You need quite a big real estate for your amplifier. But that comes with all the parts as well. It's got these 10 microfarad film caps on the inputs. There's chips in there. So that might be an interesting one as well. I don't know anything about it though. I don't have a schematic, or I should go look and see if I can find the schematic. Quality of the board is not great. You can see here where they screwed up on the solder mask. This is gold, and then it's just no copper, and then so somebody screwed up on the solder mask, which is fine. Interesting. But if there's any other kits you want me to see or try out on the channel, I'll be happy to try them out. So leave a comment, like I said. And I'm going to end this one here. So I also plan on posting this Christmas Day. So Merry Christmas to everybody. Hope you the very best Christmas wishes, and have a Happy New Year. Enjoy your time with friends and family, and wish you a Merry Christmas and a Happy New Year. So take care, and we'll see you on the next one. Thanks for watching.